All right, optimization notes, example 6. Okay, let's read the problem. Step 1. A rectangular page is to contain 24 square inches of print. The margins at the top and bottom. Well, hold on, before I go any further. All right, so 24 square inches of print. That means for something, my area is going to be 24. And we're talking about a rectangular page. I'm just going to go ahead and get my thoughts down. Length times width. All right. Margins at the top and the bottom of the page are to be 1.5 inches. And the margins on the left and the right are to be 1 inch. What should the dimensions of the page be so that the least amount of paper is used? Okay. So read the problem, understand what they're asking. So now let's label our diagram. They give us a little visual over here. So let's see, the area on the inside, this inner rectangle is this is where our 24 square inches comes from. So that means the length is this here. So from here to here, and the width is this here. All right, so let's factor in our margins. So it says top and the bottom are 1.5 inches. So 1.5 inches here, and 1.5 inches here, and then 1 inch on either side. Let's go ahead and put those here and here. Okay, so overall, for the whole sheet of paper, we can go ahead and say this. Ooh, let's try that again, Mr. Flory. Let's just do one of these. Is going to be our width of our inner part plus those two 1 inch margins. So can I just say plus 2? And then our length or our height is going to be that initial L plus those two 1.5 inch margins. So plus 3. Okay. What else? We labeled our diagram. We understood the problem. We want to, what are we trying to optimize? What should the dimensions of the page be so that the least amount of paper is used? All right, so I'm going to state our final answer. The dimensions should be blank. That's going to be in inches by blank in inches to minimize paper used. Okay, there's where my final answer is going to live. So we need to find those dimensions, and we're trying to minimize the area, right? That gives us the amount of paper. So our optimization equation should be our length times width of the whole paper. So that's going to be L plus 3 times W plus 2. Okay, for the area of our whole paper. So unfortunately, we've got two different variables, so we're going to need to rewrite one variable in terms of the other. It doesn't really matter which one, but let's take our area formula here, and let's say our area is 24. That equals length times width. So I want to solve our function for one of those. I'll just solve it for L, so divide both sides by W. And so we get our length is 24 over W. All right, so now we can take that, and in order to get our optimization equation in terms of just one variable, let's plug that into L. So instead of L, we've got 24 over W. Now we've got our optimization equation in terms of just W. Let's see, we didn't talk about restrictions for W. Can't be 0. All right, so it's got to be bigger than 0. And can we go ahead and say it's got to be bigger than, let's just say 0. It doesn't matter. And let's see. It doesn't have, we don't have an upper level because for that area, it can be multiplying by fractions. We'll just keep it as positive for now. How we doing? What step are we on? Simplify the optimization equation. Do we want to multiply that out? Sure, let's multiply that out. Let's see what we get here. Okay, so I'm going to distribute 24 over W times W is just 24. 24 over W times 2 is 48 over W. Plus 3 times W plus 3 times 2. All right, so let's see. We got some like terms and our constants there. I'm going to rewrite this one more time before I take that derivative. And put the constant at the end. Whoa. Okay, 48. Actually, I'm going to go ahead and rewrite this as 48W to the negative 1 to make it more differentiable, plus 3W plus 30. Okay, so that's the one I want to take the derivative of. So now let's take the derivative of our optimization equation. We've got negative 1 times 48 times W to the negative 2 power plus 3, and then derivative of a constant is 0. So here is our derivative. I'm going to go ahead and rewrite that with a positive exponent. And we need to find our critical points. So let's find where A prime equals 0. Let's find where A prime is undefined. A prime undefined, we've got a W squared in the denominator. So W equals 0 is undefined. We've already said it can't be 0. So it's not gonna help us out. So let's go to our calculator to find where A prime could be 0. All right, so let's go to in calc. Oh, I didn't go to my calculator. All right, so I'm going to go into y equals. I'm going to clear out whatever's in y1, and I'm going to put my derivative in there. Got negative 48 over x squared plus 3. Okay, for my window, I don't need negative values. I'm going to increase my x max to, I don't know, we're talking about a sheet of paper 15 inches? I don't know. We can change it if we need to. All right, so I graph it, and I see one x-intercept. So that's what I'm looking for there. So second calc. I'm looking for that 0. And I want to go to the left of that point. Press enter. To the right of that point. Press enter. And what do we got? Oh, exactly x equals 4. All right, we got a whole number. We probably could have solved that one by hand then. That's all right. Okay, so we get x equals 4, or w in this case. W equals 4. Okay, so what do we do with that? We need to make a sign chart. Make sure this is our minimum is what we're looking for, right? So what does A prime tell us about A? And actually, we can go back to our graph and see that we've got negative A prime values and then positive. So negative to positive means our original function changed from decreasing to increasing, so it's got to be a minimum. All right, so minimum at x or w equals 4, since A prime sign change. We went from negative to positive. Okay, so there's our winner. So how do we interpret this back into our solution? So 4 is our W for the inner part. So this part right here, let me change colors. This part right here is going to be 4. So 4 times what gives us 24? 4 times 6. So this L is 6. So what does that mean for our actual dimensions of our paper? So 6 plus 3 is going to be 9. 4 plus 2 is going to be 6. So we're looking at a 6 by 9 inch sheet of paper to minimize the amount of paper used.